Okay, everyone, thank you all for tuning in to Chapter 4 lectures. So, in the meantime, since recording Chapter 3 lectures and recording Chapter 4, I've done a lot more work on the course shell and I've started uploading more things, so things are a little bit more, kind of in motion. So, I wanted to show you exactly what these are going to look like now so that we can get a little bit more clarity. So, this again is the home screen. I guess here, let's view as a student. Um, the announcements will still be the same. The syllabus will still be the same. The modules are now updated though. So what you can now see is you'll have the syllabus, the course introduction, these practices here. This file here, this FinOff Econ 3020 notes are notes for this class from 2007 from Professor FinOff. Um, if for some reason my explanations aren't working, these should be pretty comprehensive and should be pretty well put together. So I would highly recommend you looking at those. More similarly, these are going to be this is where the slides for the calculus review will be. If you've watched those already, this course introduction, you'll see that the videos are sprinkled in through here. You guys are probably aware of that if you're watching this video. Then there's going to be the homeworks, the quizzes, and then there are these things called dynamic study modules that will help you kind of get through the chapters if you guys are reading the chapters. I am not sure if the due dates are correct on any of these or if the points are correct on any of these, but these dynamic study modules will just give you an extra credit point if you do end up going through them. I want to reward you guys for doing something, but um, don't think that these are going to be required because I know that these are going to be a lot of points and a lot of time. So I want you guys to focus on those things, all sorts of good stuff like that. The other thing I want you guys to keep in mind is that I'm kind of taking this course from a friend. And so if these homeworks are too long, and if these homeworks are, because I know it is a 3-week course, there is some sort of an expectation here that it is a 3-week course. You are taking a full you are getting 3 credit hours for the 3-week course. So you guys should be able to do all these things. And I do agree with this. But at the same time, I also know that people exist and people have lives. And so if this is becoming too much, like, please let me know. I'm happy to adjust it. But yeah, so you will see this is what a typical module will look like. You will have the learning guide, the notes, the homework, the quiz, the extra credit study module. Given that these dates are not the due date that I wanted them to be, something tells me that the due dates in Canvas will be wrong, but the due dates on Pearson should be correct. So I'll show you guys the Pearson side before people have started jumping into these. Um, this isn't exactly what I wanted, so I hope that this works. Yep, that should have already worked. Oh. I think I need to leave student view. Um, yeah, okay. Um, in Pearson, all of the due dates are correct. I adjusted these last night. So if we go yeah, so like here, for example, all of the homeworks and all of the homeworks will be due at the end of the course. So I want you guys to be able to have all of the time to do the homeworks. But one thing that I am going to do to make sure that we are like keeping up with the time is in order for you to get your midterm for the week, I haven't decided if I'm going to just have it open or not. You'll have to do the homeworks and the quizzes beforehand. The quizzes are due the Sunday of every week. And so like you can see here, these should all be updated. So yeah, so we can look and this chapter 5 homework is not supposed to be like these aren't going to be here. But you can tell here you've got the dynamic study module. Actually, we should edit this here, but I'll fix that here in a second. You can see the quizzes here. And then what you should see is in August, you will see the next set of quizzes, and then you will see the last set of quizzes, and everything else here. So yeah, you should see everything else that is going to be due. This due date, this looks like there's a lot to do here, but if you guys are just keeping up with everything, you'll be fine. And then again, we're not doing chapters 14, 15, 16, 17, 18, 19, 12, 9, none of those, so those shouldn't be there. So you should just be looking at just the 2 through 4, 6 through 7, and the homeworks that show up here. But yeah, so the due dates in Pearson should be correct. I'm going to try to figure out a way to make them correct also in Canvas, but we'll get there in a second. And for now, let's just get back to um, the lecture. So yeah, so we're going to share the iPad again, and we will get started on chapter 4. So chapter 4, demand, is going to be building off of something super similar on what we've done before. So in this section, we're going to cover 5 main topics. We're going to derive demand curves. So using consumer theory, what we've already been kind of doing with the consumer problem from last one, and also the supply and demand stuff that we knew from chapter 2. We're going to show how a change in a product's price causes movements along its demand curve. And then we're going to see an effect of an increase in income. So imagine you get a new job that pays a lot more, the effect of and how that's going to affect your buying behavior. Then we're also going to look at the effects of a price increase. So it's going to have 2 effects, looking at changes in relative prices and the other consuming changing in opportunities. Um, there's also going to be cost of life adjustment and revealed preferences. We're not going to touch super much, like super heavy on those, because I think that they're kind of a little bit above the scope of this course, but we're going to kind of go through all of that. So first, why don't we look at this deriving demand curves idea, and we are going to first start with just kind of a recap. So what do we know so far? So in chapter 2, we knew that a price change, keeping other factors constant, causes a movement along the demand curve, right? So we had this graph, and we had quantity here, and we had price here, and we had our demand curve that was downward sloping, that if we were here, a price change caused us to slide down or slide up, either direction, right? But it caused us to slide, right? Chapter 3, we maximized our utility subject to our budget constraint to find our optimal choices. So that also helped us define demand. And then we also said that we could define a demand function in terms of our 2 goods, right? So in quantity 1, we had just our z function is a function of both prices and income, and quantity 2 is a function of both prices and income as well. So given a specific utility function, we should be able to derive the demand functions to get everything kind of figured out. So first, let's look at this first example. So how do we find the optimal choice of 2 goods for any Cobb-Douglas function? So we're going to have this utility function, and remember, our utility function is this component of our optimization equation, and our budget constraint is this second component of our optimization constraint. And sorry, I'm going to clean my iPad screen really quick while we are before this drives me crazy. But while we're doing this, we're gonna just get kind of a little bit of a um we can get 2 formulas here to make sure that these demand functions are correct. So sorry. Um, so to get these demand functions, right? Since we're dealing with something symmetrical, right, and our Cobb-Douglas function has alpha and 1 minus alpha, subject to y equals p1 q1 plus p2 q2, we have the ability that we can just kind of make a general formula to follow. So if we wanted to, we could find the first order conditions, solve for the optimal values, and then substitute back. Which is how I would recommend to do it if you were asked to derive demand functions on the exam, but I don't think you'll be asked to do that. But if we do all of that, then you're going to find that Q1 star should equal alpha y over P1, and Q2 star should equal 1 minus alpha y over P2. Um, so with all of these, essentially what you're seeing is you're seeing this thrown down in front for both, and you're getting the ratio of income to the price of the good. And we should be able to derive our demand functions from there. And so sorry again, guys, my notes just closed out of here. So give me 2 seconds to get this pulled back up. This has been a rough video already. Okay, so yes, so once we have all of this, we should be able to get our interactions between the two. And so from this, if we think a little bit more, we can come up with this example, right? So suppose that we had this optimal choice for this utility function, right? And this is where we'll do this full example. We'll use it during the tangency method, and then we'll also use it using the formula. And so we're going to get B. We have our utility by choosing B and D, and subject to Y. Nope, and this again should not have a Y equals. Should just be Y equals PBB plus PDD. So let's think again that we're doing price of beer times quantity of beer plus price of donuts times quantity of donuts. Let's derive our optimal demand. So let's do it the first way, right? So let's set MRS equal to MRT. And if we remember, the MRS is the marginal rate of substitution. So this is going to be the utility between the two goods. So our MRS is going to be the negative ratio between good 1 and good 2. So in our instance, it's going to be utility of beers over utility of donuts. And so for here, and remember UB is just the partial derivative of U with respect to B. So 0.2, B to the minus 0.8, D to the 0.8 over 0.8, B to the 0.2, D to the minus 0.2. And so this is going to give us minus 1/4 times D over B. And that's going to be our marginal rate of substitution. And our marginal rate of transformation is just going to be the ratio of the two prices. So if we have beer on top and donuts on the bottom, then that's going to be our marginal rate of transformation. And so if we set these two equal to each other, we get minus 1/4 dB should equal minus PB over PD. Then we would get something along the lines of D should equal 4 PB over PD times D. Then we would be able to take this, not a D, sorry. This should be a B. Then we'd be able to take this function and this function, and we should be able to find the optimal. And so if we come over here, we're going to get, let's just throw this function of D straight in. We are going to get PD times 4 over PB, PD times B. These are going to cancel. And we're going to get Y should equal 5 PBBs, or B star should equal Y over 5 PB. And so this would be one of our optimals. Similarly, we can go D star should equal 4 PB over PD times B star, which should equal 4 PB over PD times Y over 5 PB. And so these PBs are going to cancel. And we are left with 4 over 5 y over PD. So those would be our optimal demand functions. Um, if we came back and we were like, man, what are we actually thinking here using these formulas instead? So, right, remember, we've got these two formulas too. So if we come up here and we go formula method, then in our instance, D star should equal 0.8 y over PD, and B star should equal 0.2 y over PB. And if we notice, if we come back down here, we can see that there's a 1/5 here, which is equal to 0.2, and a 4/5 here, which is equal to 0.8, which is exactly what we found from before. So if you want to use the formula, use the formula. If you want to use the tangency method, use the tangency method, both of which will be perfect to get between the 2 points. And so now we're going to think a little bit further, right? So let's start thinking about what happens to the budget line when the price of good one in P1 falls. And if we're thinking about this, right? So let's say that we had this. Oops. Right, so we had y equals P1 x1 plus P2 x2. And we had some optimal amounts in x2. Let's say that the price of P1 drops, what would happen? Well, it would mean that our ratio, right, because we know the optimal value of x1 is going to be some ratio of y to P1. If P1 drops, then this entire term should increase, right? And so that's what we just said here, right? So this is just me writing it out. When we throw this into a graphical space, right? If this was our original budget line between, let's call this beers and donuts, right? If the price of donuts declines, then we're able to purchase more donuts for our same amount of income. And so it's going to be shifting out, right? So we're going to see this pivot this way, right? So let's come back. Okay, so let's think about all of these kind of together. Let's think about all of the possible combinations that we can deal with, right? So if we had a decline in price one, then we said that our ratio would increase. All right, so let's call this x1, let's call this x2. We're going to put this in every box because we're going to do 4 things. And remember, this ratio y over P1 comes from up here, right? Comes from these formulas here. Is that this ratio here should always be the same. And if this is a constant, the changing of P1 is only going to change the quantity demanded of Q1, right? And so we're essentially doing some fancy comparative statics like we did beforehand, but we're just going to do it like kind of implicitly. So coming back down here, right? If we had an increase in P1, then this ratio is going to decline. And then let's think about the same thing with P2. So this was the one that we did above. We are going to be sliding out. But if P1 increases, then our quantity demanded of Q1, or X1 in this instance, is going to decrease. Similarly, if we have a decline in P2, we're going to slide up on the y-axis because we're now dealing with the second good, and a decline if the price of that good increases. And so you can see kind of how these lines are going to shift and these lines are going to change. But for the most part, it should be pretty predictable and you should be able to figure out what's going to happen from each. So now we're going to start pivoting into this thing called the price consumption curve. And the price consumption curve is this fancy way of saying it's going to be our bundles that a consumer would consume at each price of the good when the other good is held constant. And so if we wanted to think about this a little bit more, um, or kind of a little bit more pointed, um, shoot, guys, my notes keep disappearing. We should be able to get the price consumption curve from the uh, quantity demand, I mean, from the demand graphs. Um, okay, here, I just need to skip ahead to see what we're going to do here. Okay, so for example, if we are thinking, and this just keeps bouncing around, why is this doing this? Sorry, guys, technical difficulties galore. Um, okay, here's this. So if we're thinking about this, a price consumption curve. So let's suppose, following from what we did up there, we had this original demand line here, right? So if we have good one, let's call this beer, let's call these donuts, and then we are going to shift out to, so this would be at price one. This would be at price two. This would be at price three. And then remember, at each of these, we also have an indifference curve that we're dealing with here, right? And so we're going to be at this indifference curve, and then we are going to have the same indifference curve, but we're going to be shifted out a little bit. And then we're going to have the same indifference curve, and we're going to be shifted out, well, a similar indifference curve. Instead of pasting these, we should probably just draw them. It'll be easier. And the same like a similar indifference curve, right? Because for each of these, we are going to be expanding a little bit more. And so we're going to have a dot and a dot and a dot for our tangencies. And we're going to be able to draw this line that goes through all three of these. And this orange line is called our price consumption curve. And it is found by taking your optimal bundles at varying price levels. It's pretty easy, pretty straightforward, but this is an indifference curve space, right? So if this is an ICC space, sorry, not ICC, just indifference curve space, we can then take these because again, each of these are going to give us quantity demanded of B1, B2, B3, and D1, D2, D3. We should then be able to take this. So I'm going to erase this. I'm just going to trim this up. We're going to call this the PCC. We'll leave this up here. Then we can go into demand curve space. So again, we're going to keep quantity on the x-axis and price on the y-axis. And let's say that this is quantity of donuts. Then at each of these price levels, so this would be price 3, this would be um at price 1, if we're moving from price 1 to price 2, that means that price decreased, right? So if we're shifting outwards, then we're thinking that price 1 is going to be the highest, price 2 is going to be the second highest, and price 3 is going to be the third highest. And we're going to have corresponding allotments of D's. And if we plot these same combinations, right, because this curve, you could think about it as D1, B1, P1, then we should be able to draw points comparing just the two of those. And if I was a good, we'll just force that one to be true. Now we have so and this is in demand curve space. We now have a downward sloping line, which is exactly what we wanted. And we are able to derive something super simple from what we learned in chapter 2 from something that we learned in chapter 3. So everything is all linked. The one in chapter 3 looks a little bit more complicated, but if we think about what we're actually doing, we're just doing the same thing over and over again. So it's just imagine that like how many bottles of beer would we want if beer cost $12 versus $6 versus $4, right? Our indifference curves are going to update, and from that, we're going to be able to derive a demand curve that varies at 12, 6, 4, and we're going to be able to purchase 1 bottle of beer here, 2 bottles of beer here, and 3 bottles of beer here. And so we're going to be able to demand a lot more, and we'll be fine. So let's take this example. So suppose we have this budget constraint, and we have 10 is equal to 5Q1 plus Q2. Then we are going to be able to take P naught is equal to 5, our Q-intercept is 2, P2 is equal to 2, and our Q1 intercept is equal to 5. Actually, I think this P naught should be a 1. P1 is equal to 5. And so if we wanted to just see this a little bit better, or actually, I think the 0 is supposed to be there. Like if we wanted to add a numeric example, right, then we are going to have um, I think our example from above should be fine with our numbers. We should be good. I don't think I gave myself enough information here to make this work, but we should be good. If you want to see this, I would highly recommend reading page 109, and it will make so much more sense. And for the next video, I'm going to make sure that I have my notes actually all lined up, and we should be good to go. But I think we should be good to go regardless. So Um, yeah. Okay, let's just keep working on this. We'll be okay, and we will catch you guys on the next video. And if this is the thing that we get caught on in the future, just let me know. I'm happy to fix it. Okay, cool. Let's look at the effects of an increase in income next time. Thanks, guys.